In the previous lesson, we used graphing to find equations of lines given two ordered pairs. Well, that's not the only way to do it. And that's what we're going to do in this lesson. Let's start with two ordered pairs. We're going to find the slope, but we're not going to find it by counting it out on a graph. We're going to use the slope formula, and the slope of this line is -1. And then we're going to remind ourselves that slope-intercept form is y equals mx plus b, and we're going to substitute the -1 in for m. Now we need to find the y-intercept. Well, in previous lessons, we found the y-intercept by examining the line that was graphed, but we don't have a graph of this line, so we're going to use another method. We're going to pick one of the 2 points that we already know and substitute those values for x and y. So the 4 goes in for the x and the 7 goes in for the y. We substitute, do some arithmetic. Now we add 4 to both sides, and we discover that b is 11. We have not needed graph paper to do this. And since we know that the slope is -1, we have our equation. And instead of writing -1x, we write it the more common way, y equals the opposite of x plus 11. We also could have picked the other ordered pair, and let's go through that. So the first part's the same. We use the slope formula to get that the slope is -1, but now we substitute the other ordered pair, 9 for x, 2 for y. Our substitution looks different. Our arithmetic looks different. We now add 9 to both sides, but b is still 11, so our final equation, y is equal to the opposite of x plus 11. You can substitute either point in for x and y to find the y-intercept after you've used both points to find the slope. Here's another example. We plug into our slope formula, apply the definition of subtraction, do some arithmetic, do some division. We get 8. We substitute the 8 in for the slope, and we're almost there. We pick one of the 2 points. I'm picking the second point this time. The -8 goes in for y, the -5 in for x. I do my arithmetic, then I add 40 to both sides, and I get that b is equal to 32. So my equation using the slope and the y-intercept is y is equal to 8x plus 32. If you'd like, you could stop the video now and substitute the other point, the -3, 8 in, to see if it also gives the equation y equals 8x plus 32. And now let's introduce another special form. This form is called Pointslope Form. If you know the slope and one ordered pair from a line, you can write the equation using Pointslope Form, where the y sub 1 is the known y-coordinate of your ordered pair, and the x sub 1 is the known x-coordinate of your ordered pair, and of course the letter m stands for the slope. The reason this form works comes from our slope formula. The difference is, instead of writing y sub 2 take away y sub 1, we just write y take away y sub 1. That still allows us to tell them apart. And of course the denominator is x take away x sub 1, and that's how we get the slope. But of course we can multiply both sides by the quantity x take away x sub 1, mark out as we do when multiplying fractions, and that's how we generate point-slope form shown here. Y take away y sub 1 is equal to the slope times the quantity x take away x sub 1. We go back to our first problem, and we're going to use point-slope form to find the equation. Well, the first part's the same, so I left it there. We've used the slope formula to get the slope as -1, as we did earlier in this lesson. But now we're going to write down point-slope form and substitute one of those 2 ordered pairs for y sub 1 and x sub 1. I pick the second pair. The 2 goes in for y sub 1, the 9 in for x sub 1, and the -1 in for m, the slope. Now I could stop there if my goal was to just get any old equation that represented the line that contains those 2 points, but I want to check to see if this is an equivalent equation to the one I did when I used slope-intercept form. So I'm going to apply the definition of subtraction so I don't accidentally make a sign error. I'm going to multiply on the right side that quantity times -1, which of course is the distributive property. And then I'm going to add 2 to both sides, and I get what I got the first time, that y is equal to the opposite of x plus 11. Here's the other problem we did earlier using slope-intercept form, and now we're going to do the same problem using point-slope form. Step 1 is the same. Use the slope formula to find the slope, so I leave that work there, and it's still 8 as it was earlier. Now I'm going to pick one of those 2 ordered pairs and substitute it in for x sub 1 and y sub 1. So in this case, -5 goes in for x sub 1, -8 for y sub 1. And later, if you want to stop the video, you could substitute the other pair in, the -3 and the 8, to see if that works as well. And if your work is correct, it will work. Well, let's get back to the point that I chose. We've now shown the substitution. We apply the definition of subtraction, and then the distributive property, and then we add -8 to both sides. And once again, we get the same equation that we got when we did it using slope-intercept form. Y is equal to 8x plus 32. To summarize, equations can be written when the coordinates of 2 points are known. Both slope-intercept form, y equals mx plus b, and point-slope form, y take away y sub 1 is equal to the slope times the quantity x take away x sub 1, may be used.